properties of logarithms, which are going to be related to our properties of exponentials. Because once again, a logarithm is the inverse of an exponential. So the way that exponents behave, logarithms should have some sort of a relationship. So to make it easier to remember these properties, let's think about what we already know about how exponents behave and connect that so that it's not like we're learning something brand new. So if I had x squared, x to the fifth, what did we do with those exponents? We added them, so we would have x to the 2 plus 5. So our multiplication became an addition. And that's what the product property says, is that if I have a multiplication happening inside of the log, it will separate out to be two separate additions of logs. Multiplication is related to addition, just like it was with our exponents. For the next one, when we did division and I had something like x to the 8th over x to the 3rd, what did we do with those exponents? Subtracted them. So division should be related to subtraction. So our second property, the quotient property, says that when we are dividing something inside of a log, we can separate it by subtracting the individual logs. And our third property is our power property. So when I had x squared to the 3rd, what did we do with those exponents? Multiplied them. So we would have x to the 2 times 3. So there should be a relationship between powers and multiplication. And that's what this last property says, is if I have a power, I can drop it down in front and multiply that power by the log. This property is going to be the most important to us when it comes to kind of solving log equations, which is what we'll talk about after we get back from break. But today we're going to be applying all three of these properties. We are going to apply them in the order of first quotient, then product, and lastly power. We are going to apply these properties on our first questions. So in our first question, we are asked to expand this. What does expand usually mean? More stuff, to make bigger. So what we want to do is make this bigger in the sense of separating each piece. So right now it's all together inside of one single log. What we want to do is separate it so that every variable and every number has its own individual log. To do that, we're going to apply those properties. The property I said we would apply is the quotient property. So we're going to take this division, and division separates to become a subtraction. So we're going to do the log of the top stuff minus the log of the bottom stuff. The base will stay the same for every log. So since it's log base 2 in the beginning, throughout this whole problem, they're all going to be log base 2. The goal in the end is that each individual log should have just a single letter or single number inside of it. So that second part, log base 2 of y, it's good to go because y is all by itself. But that first part still has too much stuff. So the second property we're going to apply is the product property. Since this is 7 times x cubed, we're going to separate those. And the product property says that we separate by adding the individual pieces. And that log base 2 of y is just going to tag along. So the 7's good because it's all by itself.
Are we going to have to memorize?
Yes, you need to know how to apply these properties. Not memorize them like I would memorize the formulas, but just like we learned a while ago that when we multiply, we add exponents. You need to know that when we have a multiplication. So the 7's good because it's all by itself. The y is good because it's all by itself. But the x cubed is still on inside of it. So we're going to apply that last property that says that we can take a power and drop it down front as a coefficient. So we're going to have log base 2 of 7 plus 3 log base 2 of x minus the log base 2 of y. And that's our final answer. Some reasons why we may want to do something like this. Back before calculators were really prevalent, there were tables that would say log base 2 of 1 equals, log base 2 of 2 equals, log base 2 of 3 equals, log base 2 of 4 equals. You think so this way we can look up what individual logs are instead of having one large thing to work with. It could also be helpful. So even though we do have calculators now, this is still an important skill algebraically to be able to solve equations.
What did you say again was the order of the properties?
First, when we're expanding, we're going to do the quotient property. And second, when we expand, we're going to do the product property. And then the last property we'll do is the power property.
You do them like that all the time?
When we expand, we'll always do them in that order. Every time we expand. You know when you're finished when inside of each log there's a single number or variable. So inside of the first one there's a plain 7. Inside of the third one there's a plain y. So we know we're done. Okay. Go ahead and give this one a... So this one doesn't have any quotients, so we just don't need to apply that property. So the first property we're going to apply is the product, since it's 2 times x to the 6th. So we're going to do log base 5 of 2 plus log base 5 of x to the 6th. Multiplications separate out as additions. Then the 2 is fine because it's all by itself, but the x to the 6th still has too much stuff going on. So we're going to take that power of 6 and drop it down in front as a coefficient. So we get log base 5 of 2 plus 6 log base 5 of x. And that's our final answer. Or variable. Questions? Our next type of problem is exactly the opposite. Here we're condensing. What does condense mean? To make smaller. So what we're going to do is take all of these individual logs and put them all together inside of one log. So it's exactly the opposite process of the first type of problem. So we're going to do our steps in the opposite order. So the first thing I'm going to do is take care of coefficients and make them into exponents. That was the last thing we did when we were expanding. It'll be then the first thing we do when we're condensing. The next thing we're going to do is take care of any additions. And when we put together additions, they're going to become a multiplication. And the last thing we're going to do is put together subtractions. And when we put together subtractions, they are going to become division. The first part divided by the second part. Because all of this is just numbers, we can do some arithmetic to clean it up in the end. 2 squared is 4, times 6 is 24, divided by 3 is 8. Just kind of working out that arithmetic in there. There was no base written on this question. What does that mean? The base is 10. Now, one important thing to note about condensing is you can only condense or combine logs that have the same base. So they all must have the same base. These all had base of 10. This is not something that you want or that the textbook one. Working with exponents, if I have something like x to the 3rd, y to the 4th, I couldn't put those together because the bases were different. So same thing with logs. I can't put them together if the bases are different, but I'm not going to try to trick you on that. Everything I give you, they will have the same bases.
Alright, what would happen if we did something in like a different
If you do the proper order, you could operations problem. So it's just kind of like solving arithmetic. If you don't hit the answer, that would be the problem that would happen there. Go ahead and give this one a shot. First thing we're going to do is the power property. So I'm going to take the 2 and bring it up as a power, take the 5 and bring it up as a power. So I have log base 3 of 7 squared minus log base 3 of x to the 5th. Then the next thing I would do is the product property, which would put together any additions, but I don't have any additions. So then I'm going to do the quotient property, which puts together subtractions. So log base 3 of the first part divided by the second part. And since 7 squared is all numeric, we can do some arithmetic there to get 49 over x to the 5th inside of the log. Okay. Questions? The last type of problem for us today is going to be a change of base formula. This will allow us to evaluate any log on our calculator. So the calculator is programmed to only be able to evaluate a log of base 10, the common log, or the log of base e, the log. So if I wanted to know what a log with a different base was, I could calculator. But this formula allows us to change the base. It looks confusing with all of these symbols. So instead of thinking of all the symbols, I just remember it in words and say that it's the log of over the log of base. So what that looks like with numbers is that on this one I would do the log of 7 divided by the log of 3. The log of the thing that was inside divided by the log of the base. And then since this is just a plain log, I can type it into my calculator. Or you could write it as ln's as well. It doesn't matter whether you do the log, you do the same on the top and the bottom. So if you do log of 7 divided by log of 3, what do you get? 1.771. Now let's remember what this means, because a lot of times once we start plugging stuff into our calculator, we forget what's really going on. So that's our answer. What that means is when we evaluate a log, it's giving us an exponent. So it's answering the question of 3 to what power would equal 7. A log is asking the question of what exponent would give us that answer in there. So 3 to what power is 7? About 3 to the 1.771. Okay? That's the answer that a log is giving you when you evaluate a log. So that's a way to check your answers on these as well.
So if it was like log, so if the original problem was log base 3 of 9, then if you did that of log 9 divided by log 3, it would just be 2. So
Yes.
3 squared is 9.
Yes. So in this one, you can use the log or you can use the ln. It doesn't matter. I'm just lazy enough that a lot of times I will do ln because it only involves writing 2 letters instead of 3. Like, sadly, it's true. I'm that lazy. But it doesn't matter whether you do log or ln because they both work as long as you do them the same. You can't mix and match. Do not try to simplify anything. A lot of students will try to divide and say, oh, 8 divided by 4 is 2, and then just do the ln of 2. That will not give you the same answer. Don't simplify it at all. Type it in just as it is, and what do we get? 1.5. So that's our answer, and what that answer means is that 4 to the 1.5 should be equal to 8. Okay? That's what a log is doing, is evaluating an exponent. Questions? These last few examples are more of the same type of problems as our early questions, but something to address. So in expanding, turning it into a subtraction. So I'm going to have log base 7 of y minus log base 7 of 3x squared. Then the next property we applied was the product property to separate that 3 from the x squared. Now when we do that, we are subtracting everything after that minus sign, so I need some parentheses when I separate it. We're going to need to distribute that negative because we're subtracting everything after that minus sign. So when I split up the 3 and the x squared by addition, I really need to distribute that negative through. So everything's going to be subtracted there. The final property we apply is the power property, taking that 2 on the x and dropping it down. So I get log base 7 of y minus log base 7 of 3 minus, because I'm going to distribute that negative, to log base 7 of x. Make sure that in your final answer, anything that started on the bottom of the fraction is a subtracted term. Just like, what do negative exponents do? What do we do with a negative exponent? Negative exponent goes to a bottom of a fraction. Something that's on the bottom of a fraction should be a negative. That negative.
But why couldn't you do that just from the start?
You could, if you know that you're supposed to do that, but what will happen is a lot of students will write the second line without the parentheses, and so that they have this last term as being a positive term. If you just know that everything that's on the bottom needs to be a subtracted term, you can just write it all as subtracted terms. The next problem is the condensing of that. So the first thing we're going to do is take care of the powers. That's our first step in condensing. So any coefficients are going to raise as exponents. And then, like we said in the last question, any term that has a negative should have come from the bottom of a fraction. So we're going to write this as log base 8 of. The x squared's positive, so it goes on top, but the 5 and the y cubed were negative, so they go on bottom. Anything that is a subtracted term belongs on the bottom of a fraction. Questions? One more change of base problem. We would do log or ln of the of divided by log or ln of the base. And again, don't try to do any reducing. We cannot reduce that 15 and 6. We just have to type it in just as it is, making sure to close parentheses. And I get 4.852. No, I don't. I missed my division sign.
1.511.
That sounds like a better answer. And the reason I knew I had a wrong answer is because I'm thinking about what a log means. And 6 to the power of something should be 15, and I knew it wasn't going to be 6 to the 4th. Because 6 to the 4th is going to be a whole lot bigger than 15. Okay. So you can think about that as a way to check your answer. Your homework is from 8.5.